Swayam Prabha. Digital India. Educated India.
Today we will have this lecture number 4, where we will be discussing Van de Graaff Accelerator, tandem and peloton accelerators. You saw that in earlier lecture that in Cocktrot-Walton type of accelerators were open air type, and therefore the voltage maximum voltage that could be achieved was in the range of 1.25 to 1.5 million volts. Van de Graaff is an improved version of that. That means if you put that whole system inside a tank, then and fill it with the high insulating gas, which has a dielectric constant higher than the air, then it will go to higher voltage. The breakdowns will be much less. So this principle was used by R.J. Van de Graaff, and 1929 he developed an accelerator called Van de Graaff Accelerator. In Van de Graaff accelerators, a high potential difference is built and maintained on a conducting surface by the continuous transfer of positive static charges from a moving insulating belt. Now, the material of this insulating belt in the beginning was nylon or the rubber, and the surface on which this charge is transferred is called high voltage dome or high voltage terminal. Now, is shown here. This is the high voltage dome, and this is the pressure vessel, and this pressure vessel is filled with a high dielectric constant gas. For example, in the beginning, it was filled with nitrogen plus carbon dioxide gas at much higher pressure, sometimes 250 psi or so. As a consequence of that, the dielectric constant around this high voltage terminal was increased, and the breakdowns were avoided, corona formations were avoided. Now, how the voltage generator is different from Cocktrot-Walton is that here the charging of this capacitor takes place by transferring the charge through the belt. This is shown here. And how that takes place? That takes place that suppose you have a comb which has a lot of sharp points, and you apply a positive voltage here, then this belt is running over two pulleys, one inside the high voltage terminal and other one is grounded. Then because of this sharp point there will be high field, and as a consequence of that, this gas in this region will be ionized, and positive and negative charge particles ions will be formed, and positive ions will be attracted by the grounded pulley and they will start moving. Between these two, there is a belt running at high speed, so as soon as these positive ions start moving towards this, they will be collected by this belt, and there will be transfer to this. And inside this high voltage terminal, then there is a similar system which takes away the charge to the high voltage terminal. And it is going to the inside of this, and since by electromagnetism, this whole thing is a equipotential surface or volume, and therefore charge cannot stay here, then the charge goes outside. So basically this high voltage terminal along with this grounded pressure vessel forms a capacitor which is charged. A charge is transferred by this, and then this voltage will be raised to this. So this is a high voltage terminal. Now if you install an ion source here and put a evacuated accelerating tube, then these ions will be accelerated because of Coulomb repulsion. Now, as I mentioned in earlier lecture, that you have to have several electrostatic or equipotential surfaces. That means there has to be a gradient here, and that gradient has to be generated or has to be maintained through a series of resistances here. So these are resistances. So suppose V is the voltage and total resistance is R, then there will be current passing through this resistance chain, and that will be V is equal to IR. Then there are, so that means this is a current again passing through this. So this has to be equal to this. But in addition to this, there are several other leakages paths. For example, there is a corona formation here, and that is intentionally done for voltage stabilization. So that also has to be taken. So different components of this Van de Graaff accelerator are pressure vessel, high voltage terminal, the insulating belt is either nylon or the rubber, and then it is a high voltage column section which maintains the potential gradient. The R, of course, is if there are n number of resistances put, will be multiplied by R naught, which is normally it is all R naughts are equal. So it is R, total R is equal to n into R naught. Other components of this are the charge carrying dome. This is charge carrying dome. Then there is an ion source here which generates positive ions here, and when they are extracted towards this, then in this accelerating tube, they are accelerated because of this potential gradients. So these are gradient resistors, the accelerating tube. And then of course, once the beam is coming out of the accelerator, you would like to know the exact energy, and that is done by analyzing the energy using an analyzing magnet. A proper magnetic field is put into that, and that will tell you the exact energy. Of course, always there will be some variation in the voltage, and that has to be corrected. Most of the time in the beginning, these Van de Graaff accelerators were used for nuclear resonances studies, nuclear structure, where there is a requirement to have a fixed energy with minimum amount of variation. And therefore, there should be some mechanism that if because of several paths, leakage paths, there is a fluctuation in the voltage, terminal voltage, that should be automatically corrected. And that is done by giving a feedback through the slits. Here you can see there are two slits. Opening is only 1 or 2 millimeter, and through which the exact energy particles will go. So if they are the energy changes because of change in the voltage, particle will fall either on A or B depending upon the energy is increased or decreased. So if it is falling on A, that means the energy is low. If it is falling in B, that means energy has increased. Energy is directly proportional to the voltage. That means there is a variation and that has to be corrected. And by putting a feedback from these slit resistances to a system which is here, is called corona feedback system, the voltage of this terminal, high voltage terminal, can be stabilized. And in Van de Graaff accelerators, it has been possible to stabilize the voltage to 1 to 2 kV in the tens of million volts. Now, you would like to ask a question that high voltage is at high voltage terminal is at high voltage and you are taking the charge from the ground potential. So how the ground potential charge will be able to enter inside the high voltage and raise it to further voltage which is at high voltage. So it is against the principle. So can we do that? And that is demonstrated in this slide that yes, we can do it. And that is demonstrated. Suppose you have two spheres, A and B. And suppose A and B are at the same voltage. That means they are charged equally. So VA is equal to VB. Then if you connect them, then there will not be any flow of charge because both of them are exactly at the same potential. Now, second situation is suppose A is at higher potential than the B. And then if you connect them, what will happen? It will happen that if VA is greater than VB and we connect them, then charge will flow from A to B. Charge will flow from A to B till the voltages become equal. Third possibility is that VA is less than VB. And if you connect them, then charge will flow from B to A, from higher potential to there. Now, you would like to think that can we transfer the charge from B to A, where that means from lower voltage, lower potential to higher potential. In principle, it is not possible, but under certain conditions, it will be possible that if you spend some energy in carrying this charge to the high voltage and you overcome the difficulties, then this charge can be transferred. Answer is of course yes, you can do it, it is possible, and you have to spend energy and take a sphere B. One of the ways is that a sphere B inside A, and then if you just take that B inside that, that means now the A is much bigger as compared to this, and you take this inside B and touch it to A. This is having a lot of charge. If you touch it, and this for taking this you have spent energy, then you will find that this charge which was there on B, that will be transferred to A, because it will, suppose it is transferred to inside surface, and as per the electromagnetics, you cannot hold the charge there because it's a equipotential surface, and therefore it will be transferred to outside surface. So that is it. And this is the principle of Van de Graaff accelerator. You have seen it here that charge is taken and that extra energy is spent by this motion of the pulley. So there is a motor here which drives this pulley. So you are spending energy, and this spending energy will take care of transferring this charge which is going there inside the high voltage terminal. And as more and more charge is transferred, the terminal will be raised to higher and higher. In this case, at a reasonable pressure, the Van de Graaff accelerators up to about 10 to 15 million volts was possible. Because in the Van de Graaff, in the initial stages, nitrogen 80% and carbon dioxide 20% was used as insulating gas, and more than 10 to 12 million volts, this insulating medium was not able to hold, and therefore most of the Van de Graaff were built in less than 15 million volts. Most of them were about 10 million volts, up to 10 million volts. So in this case, in the Van de Graaff, the ion source is put inside the high voltage terminal, and the ions are extracted, and now you see that ion source, when you are producing ions, it needs some power, and there is no power there in the terminal. So that power has to be generated in order to create these ions, and that power basically is generated by the motion of the pulley, which is here, and that power is given to the ion source. And since this belt is running at a certain speed, and therefore a fixed amount of power is generated, which is available for producing the ions. And as a consequence of that, the ions of protons and alpha particles were only generated there. Heavy ions could not be generated. Of course, later on, technology improved, and it was possible to generate positive ions of heavy elements, and some Van de Graaffs have been able to accelerate heavy ions also. So these are so most of the initial stage Van de Graaffs were able to accelerate protons and alpha particles, that means He plus. In fact, that power was not enough to even generate He plus plus, because helium has 2 electrons. So in principle, you can remove both the electrons, but that power was not enough to do that. So only He plus was generated, and therefore the energy which could be obtained through Van de Graaff accelerators, maximum energy was to V into the charge. It was singly charged. So it is, suppose it is a 5.5 billion volt, the energy will be 5.5 MeV. It could not be 11 because doubly helium or alpha particles could not be produced. So I said that this is what is done, that you spend energy at lower pulley, grounded pulley, and that drives the belt with the charge, and that charge is able to go inside the high voltage terminal because of that energy spent. Now this charge you have transferred. So effectively, this is again the charge is transferred to a capacitor. And in the earlier lecture, we have seen that we have 2 plates and they are connected to a battery or the voltage source. Then the parallel plates will be developing voltage. In the case of Van de Graaff, there are either it can be just a hemisphere, or it could be, you can see that this is nothing but a hemisphere, this one. So it could be either a hemisphere, or it could be even a combination of a cylinder plus hemisphere. So the capacitance has to be calculated accordingly. Then there is another improved version of that is a tandem accelerator. And in the tandem accelerator, it is a simple coaxial cylinder. This is the pressure vessel. This is the high voltage terminal. So this forms a capacitor. So there is a system which transfers the charge to this capacitor, and the high voltage is generated. So these are mainly three types of systems are used, systems are available, and they form the capacitors which are charged, charge is transferred, and as a consequence of that, uh, the voltage. So this system was used in Cockroach Walton. This is used in the Van de Graaff Accelerator, and this is used for tandem or the peloton. And of course, how the charge is transferred, that will define whether it is a tandem or it is a peloton. So I have already explained this, that in the case of Van de Graaff generator, following components are there. That one is a motor driven belt made of rubber or the nylon or any insulating material which is suitable, and that moves between two pulleys. You can see that these are two pulleys here and here. This pulley is grounded, and this is the belt, and this is called comb. Comb is having sharp surfaces, and high voltage is applied on this. This belt is electrically charged by a brush. This is called brush or comb of metallic surface. So they have sharp points. So high electric field will be generated even for a smaller voltage, and there will be ionization. The charge is carried by the belt to the high voltage terminal. That means the charge is carried by this belt to the high voltage terminal. At the terminal, the charge is transferred from the belt to the terminal by a second brush or the comb of the metallic surface here. So, as I said, that is just reverse of that. It will transfer to the inside surface, and since charge cannot remain there, so it appears outside. And this electric charge, they get collected on the external surface of the terminal, and the high voltage is generated. Now, depending upon the geometry, the capacitors values, which is called capacitance, they are defined for one or two geometries, they are defined. For example, terminal voltage is a function of diameter of the terminal. See, if it is a small one, then less charge can be done. If it is a much bigger, and the capacitance value is given by here. So, if you put these constants into, then it is as a function of r. That means the radius of this, and this is given here. So, if you take that r is the radius of the terminal electrode. If air is used as insulating material, then for a value of R, that means resistance of about 1 meter, will have, that means you put 1 meter here, then it will have 111 picofarad. But if you have a full spherical terminal of radius R1, and it is enclosed in a grounded concentric cell of radius 2, which is the case in the Van de Graaff. It's a high pressure vessel is another electrode. So if you take this here, then the capacitance value is given by this. So you can see that this becomes so, but just by putting value of R1 and R2, you can get the C value calculated. And then depending upon charge which you are transferring here, using this equation, you can get the voltage raised to that. Now, so you see, when you are transferring the charge, how much charge you have to transfer. You have seen earlier that if you keep transferring the charge, then dV by dt could be very large, and that will be a safety issue. And therefore, you have to calculate the transferring of the charge, which is equivalent to current. So you can say that it is equivalent to I charge, and that should be balanced by different loadings which are there on the accelerator. For example, you can see here that there are different loads on that terminal. So this I belt, which is the I belt, has to be equal to mainly one is that I beam is coming down, which you want to accelerate, and let's say that is the current is I beam, and of course, as I mentioned, that the corona has to be there, constant corona current, and which has to be modulated by the feedback from the slits, and that is equivalent to I corona. And of course, the continuously to maintain the gradient, you have to have the I resistance. So these three, which are the three main components, there may be few more, but they are all very small. And therefore, this I belt, that means the amount of charge which you have to transfer using the belt has to be such that it is equivalent to or it compensates these three currents. So at least it should be equal to that.